This is an inequality. It does not have an equal sign. It's an inequality in two variables. Step 1, and I want you to follow these steps when you do this problem. I want to see each of these steps. We are first going to graph. You don't have to list them, but you need to do each of these. Graph the expression without the inequality sign, but with an equal sign instead. Okay, that's very important to notice. There's an equal sign in this. Okay, so that's going to break down. We're going to do the graph. We're breaking it down to the x-intercept and to the y-intercept. Unless you want to graph it a different way. But we know it's going to be a straight line. We let y equal 0. We get x minus 2 times 0 equals 6, which simplifies to x equals 6. And it gives us the x-intercept, the ordered pair, 6, 0. Next, the y-intercept, we let x equal 0. We get 0 minus 2 times y equals 6. So we have negative 2y equals 6. That gives us y equals negative 3. And that's the ordered pair 0, negative 3. Okay, and the next thing we want to notice, step 2, what kind of graph is it going to be? A solid or a dotted graph? The original inequality sign had an equal portion in it. And that implies that our graph will be a solid graph. If there was no equal portion in the inequality sign, that means our graph would have been a dotted graph. Now let's do that graph on an xy axis. Now I know this is going to graph as a straight line because I'm graphing this guy right here, and he's a first degree equation in two variables, and I have two ordered pairs on this graph. Let me put dots there on the x-intercept and the y-intercept. So since it's first degree, I know it's going to graph as a straight line, and because it has the equal portion, step 2 says it's going to be a solid straight line. Okay, so let's put step 1 and step 2 together here with this solid graph, a straight line that is defined by the x and the y-intercept. Okay, so now we're ready to go to step 3. Step 3 is where we test a point. I'm just going to write 3 up here. You need to show this step. You have to name your test point. Absolutely name your test point. Test point is the ordered pair xy. Well, I'm going to choose a point that lives on one side of the line, and I'm going to choose this point. It's my favorite point. I always choose it. It's the ordered pair 0, 0. It's called the location of the origin, and it's the best thing to choose if you are testing a point. The only time you cannot choose it is when that graph actually passes through that point 0, 0. Then you'd have to pick a different point that lives on one side or the other side of the graph. Now let's do the test. Write the original inequality, which was x minus 2y is greater than or equal, not equal, but greater than or equal to 6. Plug x equals 0 in there, and plug y equals 0, and see if it's true. So this is now a question. Well, this side is 0, and 0 is not greater than 6. So it failed. It failed the test. Thus, we shade the opposite side. Because it failed. It didn't satisfy the inequality. Okay, so shade the side opposite of the side that the test point lived on. So we're shading, shading, shading everything that lives on the opposite side of the graph. And everything on the opposite side of the graph is an xy ordered pair solution to the original inequality. And we're actually finished now. The picture is the solution to this problem. Every ordered pair, and these shadings go forever on this side of the line, every ordered pair in that shaded region satisfies the inequality.